Unit 4, Day 35 Notes for Calculus. This is Part 2. Um, Very similar concept, except now we're given the graph of the derivative. And that, oh, sorry, we're given the graph of the derivative, and we want to make conclusions about the original function and about the second derivative. So uh, let's do that. And again, hopefully you can kind of try to take some, not guesses, but start compiling your list in your head and see how many you get. And we're going to end up with 8 conclusions about the original function and 4 conclusions about the second derivative. So let's do that. So let's first make a sign change chart. We know that this is the zeros of the derivative, and I know to the left of -2, it's negative. Between -2 and +1, it's positive, and between +1 and 3, it's negative, and to the right of 3, it's positive. Well, what does that mean? That's going to tell me if I have any relative mins and relative max. Let's write those down. So the original function has a relative min at x equals -2 and +3. Why? Because the derivative changes from negative to positive. And again, I have then the sign change chart where we can see the derivative is negative, but then it goes to positive there. Same thing over here. It goes from negative to positive. And the original function f of x is going to have a relative max at x equals 1. Why? Because the derivative changes from positive then to negative. Okay? Okay, the next two conclusions about the original function. The original function is going to be increasing on the interval from -2 to 1. Okay, from -2 to +1. Why? Because the derivative's positive, and it's going to be increasing on the interval from 3 to +infinity. Why? Because the derivative is positive. And then we also know that it's going to be decreasing on the interval from -infinity to 2, union with 1 to 3. Why is that true? Because the derivative is negative. Let's look at some more conclusions. All right, the fifth conclusion, I look here, the derivative is a cubic function, therefore the original function must be a quartic function. While you're taking a look up at the original, the derivative the graph of the derivative, we can look and see f of x has to have a point of inflection at x equals -1 and at x equals 2. Why? Because the derivative has a max or min, which means the second derivative must have changed signs. So this max means that the second derivative must change signs. It goes from positive to negative. Here, there's a min. It The second derivative is going to be changing signs from negative to positive. Therefore, at both those points, the original function must have a point of inflection. Okay, last two conclusions about the original function. All right, the original function is going to be concave up on the intervals from -infinity to -1, and again from 2 to infinity. Why? Because the graph of the derivative, or the derivative itself, is increasing, which we can conclude that that must mean the second derivative was positive. So let's look at that. So from -infinity to +1, again, that derivative, that's increasing, and there again from -2 to +infinity, it's increasing. All right. And again, what do I know? That's where the second derivative is going to be positive. And the last conclusion, the original function is concave down on the interval from -1 to 2 because the derivative is decreasing from -1 to 2. It's going down. That is where the second derivative, which is the derivative of the first derivative, the second derivative is negative. Think all those slopes would be going down to the right. Where from -infinity to 1, all the slopes of the tangent lines of the derivative, which the derivative of the derivative is the second derivative, those are all positive, and then same thing here. All those lines are going to have tangent lines would have positive slopes. Okay? So those are the conclusions about f of x. As we said, there's 4 conclusions of the second derivative. And just in case you needed to write that down. Okay, so some of our conclusions. Well, we talked about this indirectly before. The second derivative is positive on the interval from -infinity to -1 and from 2 to +infinity. Why? Because the derivative function right here, graph, is increasing. And therefore, second conclusion, the second derivative is negative or less than 0 on this interval from -1 to +2. Why? Because this graph of the derivative function is decreasing. Okay, the next conclusion says the second derivative changes signs at x equals -1 and x equals 2. How do I know that? Because the derivative has relative extrema, which means mins or maxes, which I already have right here. And again, we've talked about that before, but I know wherever there's a min or a max at on the first derivative, then the second derivative must change signs. Okay, and the second derivative must be quadratic because the derivative is cubic. All right, that's it for part 2 notes of day 35. Day 35 notes, part 2. Okay, we'll go on to part 3, which is the last example similar to this. Then there's some calculator active questions, which we're going to work on. Okay, you're probably going to try at home.